I hope you've all had a very hearty lunch. Welcome back to the third and final phase of this workshop on AECS, Introduction into IEC Work on the All-Electric and Connected Society. This session will present the view of the IEC Strategic Group 14 on the All-Electric and Connected Society. Established in June 2023, SG14 is the strategic group tasked with providing guidance and understanding of the AECS topic to the IEC community. One of the objectives of this session is to seek collaboration of experts and also solicit feedback and new ideas on the AECS concept, methodologies, and potential directions for future work. We are pleased to have with us Mr. Andrew Evans from Gambika, UK, who will be our moderator for the session. Joining him on the dais are Mr. Klaus Wolfgang Klingner, Director Corporate Standards and Business Environment, Hager Group; Mr. Rajiv Sharma, former Deputy Director General of the Bureau of Indian Standards and Chairman of ETD 11; Dr. Rajiv Kumar Chauhan, Assistant Professor, Dayalbagh Educational Institute, Agra. I invite all the panelists and moderator to come onto the dais, and I request the audience to welcome them with a big round of applause. Now I leave the floor to Mr. Andrew Evans. Over to you, sir.
Well, yeah, thank you very much for the introduction. I will just hand over to our SG14 chairman, Mr. Klaus Wolfgang, to give some introductory words. Thank you.
So, many thanks. I welcome you to our session here of this great workshop, Enabling All Electric and Connected Society. Many thanks to BIS for organizing that. My name is, as you have heard sometimes this day, my name is Klaus Wolfgang Klingner, and I'm since more than 20 years engaged in various standardization projects. The last 7 years as Director for Standardization at Hager Group, and currently I am chair of IEC Subcommittee 23K for Electrical Energy Efficiency Products and convener of the SMB SG14 for the All-Electric and Connected Society, abbreviated as AECS. AECS is also an important topic for standardization. IEC SMB established SG14 to work on cross-cutting issues of the AECS. Our aim today present some first ideas, concepts and observations, but we want your feedback too. That is one of our main topics we want to reach today, that we get also a little bit back from you. And the moderator of these sessions is one member of our strategic group 14. It is Andy Evans from Gambika.
Thank you, Klaus Wolfgang, for the introduction. Yes, I'm Andy Evans, Technical Director of a small trade association in London, UK, representing instrumentation, control and automation. And it's my great pleasure and honour to be able to moderate this session. I'd like to just say a quick thank you to BIS and the team for the incredible hospitality this week and the efficiency with which all of the meetings have been conducted. So I would just, before I go any further, I would just like to say that we've heard a lot of detail this morning, so that the All-Electric and Connected Society is a vision that brings together electrification, digitalisation and sustainability. And as we move towards a future where energy systems are increasingly interconnected and intelligent, the IEC plays a pivotal role in shaping the standards which will guide this transition, the transformation. Can we have the presentation? I'd just like to, before we go carry on, I'd just like to explain roughly the format and the structure of this afternoon session. In contrast to this morning's session, this is more interactive. So we need some audience participation for the afternoon. It's roughly split into 3 sections. So we're going to talk about technologies required for an AECS, and then system questions and challenges around that, and then the third section on the outlook, what we're going to predict for the future, what we expect to see. So I'd just like to, part of that interaction is that you will have a QR code, which hopefully you'll be able to scan with your smartphones. Please do it now. And there will be some questions on there. So the first one, we want to just find out roughly who we have in the room, who's participating in our AECS workshop. Please feel free to scan the QR code, and it will take you to a SurveyMonkey to reply on how familiar you feel with AECS, which industry or society you've come from, and your interest in AECS, why you thought you'd like to come along to maybe find out more on what we're doing. So I'll leave you, is the QR code on the next slide as well, Johannes? So whilst you're doing that, we'll move on for the panelists to introduce themselves. We've got expertise here, distinguished expertise in the areas of industry, from academia, and also from a standards authority regulation side as well. So I would just like to maybe ask Rajiv, my friend and colleague from the Standardisation Management Board. I'm also the UK representative on the Standardisation Management Board, and Rajiv until recently also was. So if you'd just like to, we've got the resume, but if you'd like to briefly introduce yourself and just answer one question for me. What critical opportunity do we need to grasp within the next 5 years to work towards an AECS?
Thanks, Andy. Good afternoon, all of you. My name is Rajiv Sharma. I recently retired from the Bureau of Indian Standards as the activity head of standardization. And as Mr. Andy said, we were colleagues on the Standardization Management Board of the IEC. I was there from 2022 to 2025. And then, because of my superannuation, I quit that position. Yes, the critical opportunity which we are talking about, AECS, All Electric and Connected Society, it rings bells in the mind. But do we realize that we are assuming, we are assuming that electricity is available everywhere, available to everybody? That is the opportunity. When we talk of all electric society, the first thing which comes to mind is the electricity available to everybody? Does everybody have that electricity access? And we are trying to address that challenge through the work being done at our Systems Committee of LVDC and in the Working Group 1, which talks of LVDC for electricity access. That is the opportunity which we are trying to access. So I would say that we can utilize this opportunity to integrate the millions of households who do not have electricity access to them. So that's an opportunity. We must make use of this. Thank you so much.
Thank you, Rajiv. Yes, moving words, and I think everyone can agree with that, concur with that vision really to make that happen. On the far side, we have Rajiv Chauhan from University in Agra. Rajiv, could you also briefly introduce yourself and maybe suggest one critical opportunity or objective to get towards an AECS in the next 5 years?
So, very good afternoon to all of you. My name is Dr. Rajiv Kumar Chauhan, and I'm working in the area of DC microgrid systems last 10 years. So basically, the electrifications, we in the earlier sessions, I have heard about the multiple smart meters are going to install. So the thing is smart meters are going, but the reliability is there. So that is also the challenge. And if you connect the grid in this way, the higher the reliability will be there, or there's some another sources or some assets which are hidden to the users that can be also introduced in my slides. So thank you. I will discuss in the presentation in details.
Thank you, Rajiv, and I'm sure you will expand on that shortly during your presentation. And finally, Klaus Wolfgang, Chair of SG14, Chair of SC23K. Could you briefly introduce yourself and maybe suggest another opportunity we should seize?
Oh, okay, so introduction I will skip because I have done it before. But the opportunity I think we need to use, or the topic for me is the flexibility which we want to introduce and which we want to define. And therefore I think it is very important that we are in standardization, are able to overcome our silos. Here are the committees for the grid, here are the committees for application, for appliances, and we need to overcome that to install an all-electric society which has flexibility between all these sectors and install a communication between all users of the all-electric society.
Thank you, Klaus Wolfgang. Anson, who's our convener of SG14, are we able to show the results of the poll already? This is really a test to make sure that the IT works right at the beginning before we get into some longer questions. So I don't know if any of you would like to comment on that. We have mainly newbies and some basic information. So I represent quite a few people from the standardization organizations, the family. Any comments on that? Well, as we'd expect to see, I suppose people have come here to gather more information.
I hope after our session, the dark blue will be much bigger and the green one will be disappearing.
That's the ambition. So, here people are engaged, interested, want to find out more. I think that's probably enough discussion on that one. So, in the agenda, I described the first real category, the focused issue that we're going to look at is technology. Technologies that we need for an all-electric and connected society. So that's what we're going to discuss now. In each of these categories, these focused areas, we will have a presentation from one of the SG14 members just to describe what we're talking about, and then we can discuss issues raised during the presentation afterwards. So for technologies, Klaus Wolfgang, do you think you could give a presentation on those, please? Thank you.
Can we have back the slides again? Yes, great. So, yes, in SG14 we started to discuss what is the basic for an all-electric and connected society. You can find our summary on the IEC website for AECS. You see at the first, here's a link to this AECS site where you find what you see on the right side. We have identified 3 pillars for the all-electric and connected society: the carbon-free energy generation, the electrification, and energy storage, and digitalization and automation. AECS will reduce the impact of energy usage on our natural environment with every transformation from fossil fuel-based processes to an electric one. We are reducing global warming. Furthermore, we reduce costs and dependence on oil and gas suppliers. AECS is also a valuable contributor to the IEC Global Impact Fund, which aims to promote the electrification of less developed regions of the world and thereby bypass the fossil fuel stage. The link for the IEC Global Fund is given also on the slide. You see it down. We see standardization at the forefront of the AECS. There are a lot of projects which are fostering the AECS. You see here on this slide some examples. The list may be not complete, therefore we need the input of the whole IEC community or of you. So please tell us what is missing. That is what we known and what we wrote here down, but the list might not be complete. We said we started to draft a matrix of the AECS, that is what you see now here, and the link to this matrix is given at the end of the main AECS page. So when you start the AECS page and scroll down, then you see this link, and here you see the link also written in the top. We listed here 5 technologies of these areas of the AECS and shown how IEC work is linked to these technology areas. You see here the text very small, but that's only a first start. You see the details of that when you're on the AECS Challenges Technologies page. And we see here the main technologies: the carbon-free generation, the energy grids and infrastructure, the electrification and energy and sector coupling, the energy storage, and last but not least, the further enabling technologies, which includes also our connectivity, which we have in our name of the all-electric and the connected society. So that's it as a first impulse to the all-electric and connected society and the technologies.
Thank you, Klaus Wolfgang. I think we need to ask a question now to Rajiv Chauhan to really ask about how academic research and what activities, what game changers are there underway to support the all-electric and connected society. Could I invite you up? I believe you have a presentation to expand on that. Thank you. I think you've got the slide change.
So very good afternoon to all once again. About the questions. So first, how the academia is contributing for the standardization. So the academia is give the study based on they propose the different models like testing, etc. They done. This is the one aspect of the academia contributing towards the standards, and the another one is they do the pre-testings or the in terms of efficiency, performance, and safety as well in terms of electrical engineering. The third one is the academia is collaborations with the global. They are attending the various conferences and attached with the different groups of the research. So they give the opportunity for the harmonizations of the standards globally. And the next one is the academia is producing the skilled engineers and policy makers, which will be more useful for the futures. At the initial stage, they talk about it with the students. Now come to the main presentation. So the integration of the renewable energy resources and the electric vehicle with the grids. So this is the structure of our traditional power system globally, we will see. So based on this structure and based on the availability of the sources and the traditional structure, we can classify the sites of this system is the isolated sites where some of the population, around 8% of the world, is still living in the dark, means they don't have the electricity connections at all. The another one is like the, we can say the grid connected sites. So grid connected is also maybe classified into two categories. One is the like fixed price based, as we have in most of the remote areas or even semi-urban areas in India as well as in the other countries. So fixed price, but they have the like still 24/7. And the next one is the variable price based, like in the metro cities or some of the developed countries, they have the continuously fluctuations in the price. So how can we integrate the electric vehicles or with this type of different sites? So the constraints will be different for all the case, all the sites. Then next one is the poorly available. So poorly, like we have a grid available. We have, the user has the grid connections, but the availability of the electricity is for few hours. Like the Indian government has just last year they have introduced like the Pradhan Mantri Ujjwal Yojana. So they are, the main focus is like we are going to integrate the multiple solar systems at the residential buildings. It's either on the like the highly reliable sites or the poorly grid connected. So in that case, like if the grid is not available, they are giving the options like you can feed into the grid. But whenever, what will happen when the grid is not available? That's the another constraint. That is the, like based on like whatever the invest you have done for your plant, that is like the curtailment cost will be the another pictures, but that's not coming to the utility. That's why people are not bothered about it. So like here, you can see like the photovoltaic power plants. Like we have the photovoltaic plants which is connected with the grid, but the reliability of the grid is important here, because if the grid is not reliable, the production will be waste here. So the another maybe like this type of, we have the like on-grid solar systems, charging stations. This type of setup is also available in the like a few of our university as a test bed available. In like in, for example, in my knowledge, the Central University of Haryana has this type of setup over there. So here again the reliabilities that come into the picture. So if the grid is not available in the night times or whenever the solar is not, means solar system will work in this situation only whenever the grid will be available. Otherwise it will not supply to the, it will not charge the vehicles at all. So for this type of problems, like we may keep a storage setup just close to the site, but the cost will be coming to the pictures. And like the battery bank, it's not like a water tank. It has their own efficiency itself. Like if you are charging and discharging, so losses during the charging and discharging because of the electrical circuits inside the battery, because of their constrictions, that is their losses will also important. Like most of the electrical vehicle manufacturers, they have the constraint. They are talking about the 50-minute cycle, 50 minutes or like this. They talk about the 20 to 80% charging. They are not talking about, they are not giving the time band for the 0 to 100% like that much fast. Because of their internal structure, they have some limitation of feeding current in and out from the vehicle, from the battery. So like this is the another challenge. Like our traditional system is not available for increasing the another load which is coming now, electrical vehicles. So we have to change the either the distribution like transformer here, and can we do something like so locally loads should be managed so that the minimum burden can be done on the traditional power system. Can we make the system supportive for the grid itself? So now if we come about like the which type was more comfortable or where we are moving, like either on the traditional AC systems or the DC system. So if we talk about like the generating stations, so now the globally the one race is going on, like we need to integrate the more renewable energy so resources. And here we can see the most of the renewable energy resources are DC in nature or very easily converted into the DC easily. Now, if you talk about the different types of appliances in the either the residential or commercial buildings, so we have like the LED bulbs, etc. And these are DC compatible or neutral for the DC itself. And some advancement is also in the machines as well, like the DC technology based. If you talk about the storage, we have the battery, and either the electric vehicles is also the nature is basically DC. So we basically require the less number of converters if we are going with the DC distribution system, and if we have like the grid connected or either the isolated renewable energy resources. If we talk about like this is the one of the case study I have done many years ago. Like here we have considered a complete DC distribution system where we have completed or consider as a like all the appliances are DC in nature, as well as we have a like AC distribution system, which we have even inside this building. We have the AC distribution system, but the most of the loads are DC compatible. So these are the like, if you talk about the efficiency of the appliances with the DC technology, here we can see in the list in details, and the number of converters inside the appliances or outside the appliances which are visible to us, and the efficiency is also like cause of the losses inside the system. So this is all about my today presentation. So thank you.
Thank you very much, Rajiv. So, yes, thank you. And we've had the introduction from Klaus Wolfgang and Rajiv Sharma. So how can countries, different economic evolutions or stages move towards an all-electric and connected society, and the battery technology is involved with that?
Thank you, Andy. Yeah, it's good that you stressed that development is economic development, yes.
Yeah.
So because development has different dimensions, and let us see the development dimension connected to the economic development. See, if you see the world ecosystem, the landscape, there are 193 countries in this world based on the United Nations. And out of these 193 countries, there are 59 countries which are economically developed. They call themselves Global North. And the remaining 134 countries, they are in the various stages of development, economic development, they are called the Global South. So now we are talking about the different stages of economic development in terms of Global North and Global South. So when we say North and South, India is in the Global South, no doubt, but we are strongly emerging as the voice for the Global South. We are, in fact, in a position to lead the entire Global South towards that position of development. And that's what we are doing. And if we slightly step back a little and understand how the economic development took place in the nations which are economically developed, we'll have to go back a couple of centuries. We'll have to go to, in fact, the Industrial Revolution. The Industrial Revolution, the first Industrial Revolution started in 1760 and went on till 1840. That was on the back of steam power, factories, and lot of mechanization, right? And the second Industrial Revolution, which happened somewhere in the 1890s, that was with the advent of electricity, automobiles, rapid industrialization, mass production, all this. So that is how the industrialized countries, which are developed countries, that's how the development took place. And that's how the model has been continuing so far. But if you see that environmental issues were never a concern while this development was taking place. A lot of fossil fuels were being used for powering those factories and energy sources. But that is not the position now. Now the position is that we are much more environmentally conscious. And the way the energy was being generated over a couple of centuries earlier is not the right thing to do now and into the future. We have to find alternatives. There has to be a transition of the way the energy is generated and used. That is the crux. And that's why, that's also the concern for the global environmental community when they talk of the developed nation, the leaders of the countries sitting together in the Conference of Parties, the climate change conferences. In the COP26, our Prime Minister gave the vision of Panchamrit, which is a 5-pronged strategy for addressing the climate change and also addressing the transition of energy, the energy transition issues. We are talking of generation capacity which is based on other than fossil fuel. We are talking of increasing the energy requirement, meeting the energy requirements at least 50% using non-fossil fuels, the renewable energies, cutting down the energy intensity by 45% of the economy, the GDP, and then reducing the total emitted carbon emissions by 1 billion tons by the year 2030, and of course, reaching the net zero target by the year 2070. These are the strong commitments of a nation in the global south to meet the climate change commitments. This is how India looks at it. This is how the global south must look at it. In fact, when we talk of environment, it's a shared resource. Everybody has the same resource. Global, it does not differentiate north and south, developed and underdeveloped and developing. So everybody has to show its own commitment towards the climate change and mitigating the harmful effects of the climate change. So that's how we look at it. There are global issues and the solutions must be global. In the standardization community which we are doing in the IEC, we are the global community of technical experts sitting down and finding solutions which are globally relevant and applicable to the developed as well as the developing economies. This is how we look at it. This is the way everybody has to sit down and collaborate and come out with solutions which not only help us in our ability to meet our present needs, but do not compromise the future generations to meet their own needs. That is the basic crux of sustainability, and that's what the standardization at national level as well as the international level must address. And that's what we are doing at the IEC.
Thank you, Reggie. With a round of applause, I think. That's a fascinating insight and perspective, and I'm sure that will spark some thoughts amongst the audience. So there will be some, before I'll give you a chance to ask a question in a second before we go into our second poll. So are there some roaming mics around for any questions? Before we ask the audience, going back to talking about purely technology, are there any particular technologies that are fully matured, or technologies which need more development? Are there any? Have you got any views on that? Maybe starting with Rajiv on the end.
So, whenever we are going with the advancement in the technology, or so as I have shown in my slide as well, the reliability, we are just trying to, why we are getting the power cut etc. on the different time instant in the developing countries. So this is not only the one thing we are going to increase the generation again and again. Means that's the one thing we need to fulfill the energy, but the another one is the peak power is the another parameter over there. So if we have the large size of power plants, so but if the generation rating at particular, the number of units may be generated matched, but if the power rating at different time instant is not matching, that's the main cause of the power cut at different. So if we manage the things in this way, some power saving inside the buildings, so that target can be also matched with the grids. And if we increase the reliability of the grid, so the renewable energy resources which are distributed in nature, as the residential levels, that can be feeded, that can be 100% utilized to feed into the grid. The another one is as I have shown in the slide, the electrical integration of the electrical vehicles. So their integration is the another challenge. So that's looks like a challenge, but it could be the future solution, because for a one house, if I'm talking about a small house of a a remote area, of a village, so the power, they have around 1 kilowatt of inverter generally to fulfill their energy demand whenever the grid is not available. but the rating of the generally electrical vehicles is around 30 to 40 kilowatt hour. So can you imagine how long an electrical vehicle is fully charged, how long it can supply to the residential load? And they don't have the everyday use of electrical vehicles. So like they have like a 50% use, like if they are going for 50 kilometers or like this, but remaining time their vehicle will be at home. So the vehicle can feed into the grid, and in this way, like we don't require the additional energy storage devices inside the buildings, and the neighborhood management can play an important role in this. And even one of my study published in 2017 on real-time price-based energy management system. So in this, I have covered like the microgrid system, in which we have the electrical vehicles, we have energy storage devices, compact size of storage, and then we have the automation system inside the buildings. So that's give like the energy management in this way, like all the assets get the benefits and they save around 10 to 15% of the energy saving. So this is the another prospect we need to think in.
So would you describe that as a mature technology?
That results was earlier in 17. I have just done it on the simulation level, but now we have our own microgrid system in the Albag Educational Institute. And the good thing is, like, it's a 48 volt DC distribution system at commercial level. Like, we have 100 feet long and 40 feet of the dimensions of the hall, and we have a complete DC distribution system, in which we have like the solar system, we have the DC fan and tube lights, etc. And the another, like the constant is coming, like whenever we are talking about the energies, renewable energy intermittency, like the flux, they are varying with respect to time or available. So we need to integrate the energy storage devices with this, and these are like battery bank, etc. So they are basically chemical in nature. So that's also, we can't say that's 100% green energy. So to reduce or to optimize their size significantly, we have used water pump systems, which is storing the energy in the form of water, and we are using the regeneration over there. So now it's a mature technology over there. And the good thing, why it's coming about, if I talk about the voltage safety perspectives, why it was coming my mind and why I was dedicated it, because when I start my PhD, that time my boy was just 6 months old. So he will always put the fingers inside the socket, and I always remain in the fear that what will happen if he'll. So at 48 volts, the humans is completely safe because it will not get the electric shock. And if we talk about the ratings of the DC appliances, these are more energy efficient, as I have shown in my slides, and the different energy efficiency of the appliances. So thank you, I think.
Thank you. Thank you very much, Reggie. Klaus, Wolfgang, or Reggie, would you like to comment on any particular technologies, or should we go to the audience first? Any questions from the audience, particularly about technology here? We're going to move on to systems and outlook later on. Any questions on technology? There's one in the middle down here. Any other hands up? Oh, two down here. Another one up there.
Good afternoon, sir.
Please introduce yourself.
We are speaking about vehicle. Why we can't use this in fishing boats? Can we use? And fishing boat, there is nothing in the air. It is in the sea. So can we do this? Thank you, sir.
If I heard you correctly, you were asking why we can't have electric fishing boats. Is that correct? Yes. Yeah, that's it. Anyone? I don't see any reason why we can't, because I've heard of other electric marine vehicles.
There are still some vessels in operation, I know, but it's a question of the distance you want to take. I'm living in Germany near the biggest river of Germany, and I know in the city where I'm very often, there is a ferry between both sides, which is working electrical. It's very nice. It's silent. It's really a great thing.
No, at least light,
Okay.
because in Kerala, the boat owners are running for kerosene.
Okay.
They want to light. So,
It's good. Yeah.
so at least light can we do with this solar?
We'll need to be quick because we'll need to move on to
So
other questions.
I'll give you a short answer to that. Yes, we are aware about pilot studies in Kerala for fishing boats to be running on electric. There are pilot projects going on, but we can talk about it in details. Those details can be collected and provided to you.
Thank you. Thank you for your question. And this gentleman here, please could
Yeah,
you
sir.
introduce yourself?
Yeah, thank you. My name is Sharad Sadhu. I have a background in broadcasting and electric systems. The concept which Dr. Rajiv Chauhan put forward is quite interesting. What he says that don't use AC power of 220 volts, 48 volts DC, which seems to be more efficient, as he demonstrated. And then he says that even the storage batteries are not eco-friendly. That's a very important input that he has provided. And now he has elaborated, which was also known previously, but now he says the technology of storing electric power or power in storage tanks is probably the way to go forward. Now, I think he has painted, or all of you have painted a new paradigm, a different paradigm of generation and use and storage of electricity. And if it is possible to know more about it here today, that would be very nice, because that's something which we are very excited about, particularly when there are millions and billions of people involved in cities and in countries, which is then to be installed and put together in a vast, very vast number of people and huge populations to be covered. So I do hope that your committee is looking into this in a focused manner, not only sort of limiting itself to the traditional storage of batteries, but into other non-traditional areas. Maybe in addition to the water storage, there may be something else where we can store energy. So that might be a good idea to look at and promote among the people like us. Thank you.
Any response to that? Or? Yep, quickly.
Yeah, so actually I have done multiple this type of study, and because of time, I would like to say tomorrow, same time, I am going to take another session in which I am going to show how smarter way we can use the different energy resources which can optimize the carbon emissions, as well as which can reduce the size of, or we can optimize the size of energy storage which are not environmental friendly, like batteries, etc. Because we are just saying that the battery is the chemical, but the like the carbon emissions which will be put in, like whenever we are taking out the different metals which is used to make the battery, that's also the constraints. And that's why initially I think so, very recently I've go through this, like they are giving the 8 years of electric vehicles manufacturers giving the 8 years, because I just calculate that how long this particular vehicle can save the carbon if I have electrical vehicles and the another one has the fuel based like petrol or diesel. So the carbon difference between to run the 50 kilometers per day and the carbon emission produced to make the battery of the electrical vehicles is approximately same. I'm not taking it commenting on based on the study, but just I have read it this type of statement, so I'm just convincing. But tomorrow I will discuss about the various smart methods which can be used either grid connected, isolated, as well as 24/7 like flexible price based systems, and how smartly we can use it in the future.
Thank you. Could you, apologies, we will have another chance to ask questions at the next round, but I'm keen to get on to the next poll. Those that have just arrived just at the right time to scan the QR code. and have a look at the questions here. So this is continuing on our first theme, our focus theme on technologies. So the first question will be carbon-free generation technologies, and such as wind, solar, hydro, all of those, electrification, electric infrastructure, and digitalization. Then the next set of questions will be on, as we just discussed, how mature do you think those technologies are? So the first round of questions was about the technologies themselves. The second set were how mature do you believe those technologies are? And then the third question is an open text question, what have we missed? And we're looking forward to hearing from you about technologies that we may have missed. And when we had a look at this yesterday, there were some interesting ideas. So please take some time to do that. Has everyone managed to scan the code? Right, that should be enough time to. So I mean, the poll will stay open, but is it possible to look at the results as they come in while they're coming in? Still coming in. So, if we're looking at which technologies are the most important, there seems to be a fairly even a lot of essential and important. Less important is fossil fuel, which we'd expect. Less important, nuclear fusion and geothermal, which is interesting. Less important, marine energy. Any comments to that, Klaus?
It is. I think the answers will come in step by step. Now you see the solar seems to be the most important for the audience, but that is also linked to what you said before. We need also to discuss how we can store it, and for sure, batteries at the moment is not really the most ecological way to store energy, the current technology. So here, when we are talking about technologies which we need to develop further, where we need to invest, I think here storage is really a topic where it is worth to invest in it, because the energy from the sun is a gift from the sun, and as it is typical for gifts, you do not get the gifts when you expect them, so you get them when you get them.
Excellent. And can we move on to the maturity of those technologies? Have we got those results? That's I believe a summary of how important we believe that each technology is. How about the maturity? Do we have that? So we believe PV and nuclear energy is the most mature, which would expect, I would have thought. Biomass, is that fully mature technology? Wind, I would have thought wind would be a fully mature technology. Any comments on that? Rajiv, you've got any comments?
Discussed in the earlier sessions, most of these technologies are already there. We have standards on most of these technologies. But it is also correct that most of these technologies are always evolving. They are further improving all the time. Like battery storage, we have continuous developments taking place in each of these technology areas. So, and the results of this poll obviously depend upon the perception of the people who have voted for this, and depending upon the suitability of that solution in that particular geographical area they're talking about.
That makes sense. And then have we got any of the anything about what we're missing? Binary power. I guess it's going to be difficult to display all of that text. I mean, needless to say, the results from this poll will be taken on board by SG14. That's an input into that. So unless there's any more comments on storage is still in development. We've got here DC systems still in development. Should we move on? So with these when these technologies, the technologies are powerful, as we know, for generating the power, but obviously they don't operate in isolation. So that's why we need to look at system challenges. So I suggest we move on to the second focused topic of system. Let's turn to system level questions. And I'd like to invite a previous guest back onto the stage, Johannes Stein, principal expert from DKE in Germany, to give a presentation or just introduce the subject of system level challenges.
Yeah, I try to be quite short, and most of the things have already been discussed also in the morning session. So here it is shown that we have a complete system with different sectors, but these sectors have to be integrated to each other. First, with energy. We were talking about power to heat, power to gas, and so on. But we also need to integrate them with data, with information. And this was also shown in the morning. So we see that new requirements are coming up. They need new solutions, but the new solutions are providing maybe new challenges. And so we need maybe for these new challenges also new solutions again. So this was also provided in the morning, discussed. And so we aim for a new stable system. So it's a question now that we have system questions which are coming up while we are transforming our power system. And we try to map that. We have on one side, this was already presented by Klaus Wolfgang, the technologies, which are mostly already available. On the other hand, we have system challenges, key transformation challenges, as we call them. And then you see in the middle, here are use cases, here are functions which are coming up, maybe between technology which is solving challenges, or challenges which are have to look for new technologies. And we try to use this matrix as a kind of overview for the upcoming transformation towards an all-electric and connected society. And there are new challenges, like the risks. You see here that we had a blackout in Spain and Portugal in end of April this year. We're discussing about EMC and power quality. If we have increasing electrification, we need maybe new safety protection schemes. Complexity is rising, and there are also discussion about missing inertia, increasing harmonics in the transmission system, and maybe voltage and frequency variations. And we have to integrate DC and batteries. So there are new functions needed. Some examples are given here, like fault right through, the grid-forming converters, or flexibility, which are solving maybe system question and system challenges. And one first step might be SG14 is now working on a guide for energy flexibility. Flexibility has several uses. One is balancing renewables and the demand, but it might be used also for other use cases like grid congestions, like stabilizing the grid, like market, working on the market. So that was my short introduction. Up to you, Andy, again.
Thank you, Johannes. So with that background, Rajiv, what are the challenges? Are there any particular challenges when we're talking about solutions for providing electricity access?
Thanks, Andy. See, environment is a shared resource. We all share that environment, and we don't want to degrade that environment. So energy transition is the need of the hour. We have to do it. There is no way we can continue to burn the fossil fuels at the rate which we are doing currently. All actions which are required must be done in order to meet that energy transition. There is a cost to inaction, and inaction has a cost. And if we see that the cost of inaction could be much more than the cost of the solutions which we provide. So energy transition is a necessity. Energy, on the other hand, energy is an essential requirement. Energy is required for the development of the nations. Energy is required to lift people out of poverty. Energy is required for progress and prosperity of the nations. So we need abundant energy. We want more energy to take place, but that energy needs to be clean. So when we talk of energy, it has to be not simple energy, it has to be sustainable energy. So that's what we are looking at. And that requires a sea change in the approach which we have. We have to consider sustainability in all our discussions. When we write standards, when we develop technologies, sustainability has to be in the forefront. We have to keep that as a basic objective. When we talk of having electricity access, coming to your question, when we talk of electricity access, and when we were doing standardization back in 2016 and around, see, the data was that out of the 8 billion, at that time 7.5 billion population of the world, more than 1 billion people having no access to electricity. One of the most authentic documents on quantification of electricity access came from the World Bank, the SMAP multi-tier framework. The SMAP is the Energy Sector Management Assistance Program of the World Bank, and they categorize the level of electricity access. Electricity access is not something like yes or no, or connected, disconnected, but it has different layers to it, with different levels of electricity access. When we talk of a full-fledged electricity access, we mean tier 5 of that SPAP multi-tier framework, which means abundant electricity available in a house for almost the entire duration of the day to meet almost all the requirements which are required. But on the other hand, on the lower end of the spectrum, there is tier 1, which is only about 3 watts of electrical power for about 4 hours in a day. And tier 2 would mean about 50 watts of electrical power for about 4 hours in a day. And tier 3 is about 200 watts of electrical power for about 8 hours in a day. And tier 4 is about 800 watts of electrical power for about 16 hours in a day. So there are different levels of electricity access. These are tiers 1, 2, 3, 4, and 5. And as I told you, 1 billion people having no access to electricity, they are not on the ladder. They are not even on the ladder. Zero. Not a power bulb not an electrical bulb in their households. So that is the challenge which we were trying to address. And based on the quantification done by the SMAP multi-tier framework, we quantified that into the technical requirements, and we aimed for a solution which provides households, those millions of households, who have no access to electricity, at least tier 2 and tier 3 level of electricity access in their houses. When we talk of all electric connected society, this is a too big a ratio of population to ignore. We have to keep them in the forefront. When we talk of all electric society, those people also matter, and electricity access is a priority for us in our standardization activities also.
Thank you, Rajiv. A challenge indeed. Klaus Wolfgang, any challenges or risks we need to consider when to realise a net zero future?
Yes, there's a biggest challenge in standardization, and that is to overcome the silos and pursuing a system approach. And risk, you said in the beginning that we are talking about a paradise, and as it is typical for a paradise, not everyone enters the paradise. And so here is also the risk of this transformation, because also a transformation has some losers. Some people who have invested a lot of money in some technologies which are simply no longer needed. For example, think of petrol station networks. Who need a petrol station when everyone drives electric cars? So that is, in my opinion, a big risk of the transformation, and a big blocker of the transformation.
Thank you, Klaus Wolfgang. And Rajiv Chauhan, integration of renewable energy and electric vehicles. What are the key enablers to be able to do that?
The integration of renewable and the electric vehicle, the challenges is at the poorly grid connected site is the major challenge over there. On the highly reliable sites, the challenge is just the size of the apparatus we need to, or the changes in the infrastructure, not that much, but so there is just we need to change the few components of the system. I'm talking about the distribution level. So, but in the poorly grid connected sites, as I mentioned, like the grid connected solar system for the residential customer, it will work whenever the grid will be available. If a user has installed a solar system at their site, but the grid is not available, still he is living in the dark. So, and he or she has put the lot of amount for it from their own pocket. So, some smart systems is required over there. So, can we make some system like a microgrid system which can automatically work in a grid connected and isolated mode, so that it can manage their internal sources, and whatever the not eco-friendly like the battery, their size should be minimum. One smart applications maybe in the nowadays most of the user has the geysers inside the house. Okay, so the geyser can keep the water hot for a long duration, around 20 to 24 hours. So whenever the sun is available, that time can we keep the water, can we switch on our geyser on, so that whenever we'll keep it for the next day early morning in the winter season, or in the evening whenever the user will come back from the office, that time they require the water, hot water, so that water can be used. And in this way, if we are using whenever we are consuming this direct solar electricity to heat the water, so in this way we are optimizing the size of battery as well, because the power is not going to the battery, it's directly going to run the particular appliances, smart appliance. So this type of appliances can be used to fulfill these gaps as well at the remote locations. But these are the main challenges, because our assets are just putting a lot of amount we are putting, but they are not using or not giving the reliable electricity for the user. So these are the constraints over there.
Thank you. Thank you. Interesting. Another insight that we wouldn't necessarily have thought of. But so I'm conscious that last time around this gentleman didn't get to ask his question. So please introduce yourself, and then we'll go to the next poll.
Yeah, just want to understand, because these are pointed questions to all the panelists. When you say the all electric connected, what does it mean? If you talk illumination, is just 5% of the energy requirement of residential consumers. So remaining 95% is a different energy. In fact, in one of the states, when we done the research, 20% of the energy equal to almost electricity consumed is coming from the non-commercial sources, which is like a cow dung or a biomass waste or whatever it may be. So when you say the all electric, we need to be very clear, are we talking about how much percentage of energy being used by the residential consumer is being taken care of by electricity, or what's the parameters?
Anyone like to take? Thank you.
See, when we talk of all electric society, we mean that energy being the cleanest medium of and supply of energy, we want that the conventional, the original source, the way the energy was being used earlier should now be electrified, even if it is for lighting the house or cooking or for running the industry or buildings, heating, cooling, transportation, which were using other kinds of fuels, the fossil fuels, basically to be electrified. There are challenges in that. There are certain industries or certain applications which are hard to abate. Cement manufacturing, steel manufacturing, shipping, long distance haul. All these are using conventional sources of energy which are fossil fuel based. They cannot be overnight switched over to the electricity. So that is the intention, decarbonize. As he showed it in the earlier slides, there were several aspects to all electric connected society. Decarbonization is one of those aspects, energy transition, battery, energy storage, all these things. They are collectively, and the very smart grid which allows the supply and demand to match instantly. So all these things. So it has to be smart. It has to be connected, means it has to be connected through communication, very smart, intelligent systems of communication. And it has to be decarbonized, and it has to be clean energy fuel. So that is the basic concept of all electric society. That is the future. Unless we aim towards that, we are not going to have a sustainable future for our children. So that is the aim, and that's what we are looking for. And the entire standardization community at the IEC considers this as their prime objective. And this is what we have to achieve in our future standardization. I hope I have made my point.
If I may,
but we can have further discussions. And of course, with your experience and knowledge, your contribution to this work is always welcome.
If I may, I mean, we're talking about society connected to an affordable and sustainable energy supply. That's what that's the ultimate aim, I believe. Can I move on to the poll? Maybe a last word?
Maybe one addition. When we in transferring a fossil process to an electric process, we save energy. When we look at the full energy, for example, cars, it was said earlier this day that a car, approximately 25% of the energy you put into the car is really the moving energy. So more or less our fossil cars are more or less moving heating systems and not really mobile tools.
Thank you, Klaus Wolfgang. Yeah, 75% going to heat. So, right. So we've just been. Sorry, yeah, Kishore. We'll have another chance in the next round. So we've just discussed system challenges. So please scan this QR code, and there are various questions on what the challenges may be for these technologies to fulfill an AECS. So I'll give you a moment to scan the code. Sorry, I'm standing in the way. I don't know how far away it works from me. People at the back, can you scan from the back? Yeah? Oh, there's a thumbs up at the back there. There's quite a long way away that works. Yeah, it's a big screen. I didn't know if the resolution from further back would still work, but yeah, it seems that it does, so that's encouraging. So it would be good to know what everyone in the room feels about the main challenges for these technologies, the system challenges. So can we look at the results as they're coming in? Do we get a live view of that? So that's interesting. So we're looking at, if we look at the key, very important, which is good. SG14 will be writing a guidance on resilience and flexibility, which hopefully will meet this this concern around stability and resilience of the electricity supply. Disruptive changes of energy, financing of the transition seems to be very important. Rising complexity, yeah. Any comments on those results?
Standardization hindering the transition. Yes, we need to look at that. Might be it, although we have to made a transition in standardization, overcoming the current way of only looking on a product, on our own topic. We need to look over the complete technology of electric systems, and that's, yes, there is a risk that standardization is hindering the all-electric and connected society.
There appears to be concern over the legal framework hindering the transition. System technology is not mature enough. Perhaps the system in terms of communication between the different technologies is still seen as a concern. Okay. So, societal adoption and technology diffusion. Good. Hybrid solutions are required. So yeah, but the poll's still open. Please carry on giving some feedback. So, with these system challenges in mind, let's move on to our third theme, our third focused sort of area, if you like. What does the future hold? What is the outlook for the all-electric and connected society? So I'd like to invite Johannes back onto stage just to give a brief presentation, as he did before, on the outlook.
Yeah, thank you very much. So just to mention, if you are interested in the results of these polls, we will provide the ability that you can give your email address at the end, and we will send then a short report about the poll and our discussion if you are interested. We will come to that with the latest poll at the end. Yeah, coming to our last round, it's about the outlook. And here it's a little bit the idea of what SG14, the strategic group 14 in IEC, is intending to do. So we want to provide an open forum that we can discuss issues which, with a total standardization community across committees and organizational boundaries, with industry, academia, with society, about trends, chances, risks, challenges of the energy transition towards a net zero and more digital society. We intend to increase the role of IC in standardization for this transition, existing standards to use, new standards to come, and standards to be defined. So that might be a question of discussion. And it's the aim to join forces to accelerate towards a net zero and digital future. So the open forum, unfortunately, is not available yet, but it will come soon. And until the open forum is established, we will keep these last questions, we will keep it open. So if you have something you want to add also afterwards, you can also start the poll again, the last one, and enter your additional ideas. Yeah, there are a lot of different trends which might be discussed in such an open forum. I just mentioned here some examples, and we discussed them already in more detail, and so I will not go into the details here. So there will be new trends which have to be discussed, and I think it's difficult to discuss them in one or two or a specific technical committee. Maybe we need here a broader communication. That's the reason for this open forum. And yeah, in this last round, we also want to have a little bit more of your feedback. So you might also provide a statement. If you want to have a statement at the end, which you think it's very important to be mentioned, it's now your stage, and you can give a short statement if you like.
Thank you, Johannes. So, right, we're looking at the outlook now, the future. And Rajiv Chauhan, what's the sort of roadmap or timeline for DC to dominate power systems in terms of generation, transmission and distribution?
Okay, so like as we can see, like at the generation level, the governments are already pushing to integrate the more renewable energy resources, and most of the renewable resources are like either DC in nature or DC compatible. So it will be developed earlier, like we can estimate 5 to 10 years. And if you go for like at the transmission level also, we already have the matured high voltage technology which we are using in India as well as in the other countries. If we see like at the distribution level, so distribution level, like we required some infrastructure development as per the compatibility of the system. So the integration of renewable or the electric loads which are DC compatible can be directly connected with the grid. So we require the different standards as well and the communication protocol to manage the things accordingly. So it will take around 10 to 15 years we can expect. And if we talk about like the integration, or we can say as the customer levels, so because the customer is putting the money from their pocket, they don't have any funding or other public sources, so they didn't involved in any technology until they feel it's much matured or much used by the industry. So if we talk about like the commercial level, at the user level, so it will be 10 to 15, but if we talk about the private property, it may take 15 to 20 years because they need to see the results. As I mentioned, I have a microgrid systems, but until unless it will not be, its outcome will not be like marketized by the some industrial partners, it will be remain inside the research. It's not my academic cases. We can see high level research going on in the various universities, but until unless if the research is not commercialized, it will not be visible for the users and they are not going to use it. So that may take more time at the end user, like the private properties, etc. So that's the timeline for.
Yeah, that's very interesting, and yeah, I'm glad you put a stake in the ground there to decide. That very interesting. So, Rajiv Sharma, staying on the theme of DC, how is the safety of LVDC addressed in the IEC 63318 standard?
See, that is how the standards are written. When we write standards, we have to understand the complete ecosystem around that standard. What is the problem statement? What we are trying to address? That should be very, very clear. And who are going to be the users of that ultimate solution which we provide? So here we are looking at a solution which provides electricity access to millions of households who do not have access to electricity. So we have to identify their requirements. As requirements, as I told you, they come from the SMAP multi-tier framework, tier 2 and tier 3, which lay down their specific energy requirements which are required to be fulfilled. But another thing which has to be kept very clearly in our minds is that these are going to be the first time users of electricity. They don't have prior experience of using electricity in their houses. So it has to be safe, it has to be reliable, it has to be efficient, it has to be scalable, and all these things. So the safety and the reliability of the system which we provide as solution is the most important consideration. When we looked at safety, Dr. Chauhan also referred to it, we zeroed down to 48 volts because it is safe, which is safety extra low voltage, which is anything up to 60 volts DC is considered as safe voltage. It does not cause electric shock. So that's how we zeroed it on 48 volts. Another consideration was the reliability, the efficiency, or the sizing of the conductors. Because if we lower the voltage for providing the same amount of electrical energy, the sizing of the conductor has to be a little higher because the current is higher. So that was another consideration in favor of 48 volts. That's how we zeroed it on 48 volts. And then we decided all the connections which are required, the power connectors, the safety features, the batteries, and all the interconnected architecture to make it very safe, very foolproof, reliable, efficient system. So all these considerations went into the development of that standard. We developed that draft in India using the cutting edge research being done by our Indian Institute of Technology at Chennai. But then at the international level, 14 technical experts were directly associated in writing the standard. We received comments from more than 50 countries, which were all threadbare, discussed, and solutions were provided, and that's how the standard got developed. It took us some time, but the standard is a reality now, and it is being adopted by so many countries in this world. And it is providing reliable solution to many countries.
That's great to hear, Rajiv, and consensus.
That is one of the
consensus at work.
Success stories coming out of India, where we led the development of a standard, and now that standard is providing and creating an impact across the world.
Wow, thank you. And Klaus, I mean, why are you involved in standardization, and anything in particular, something important for the all-electric and connected society?
Standards are the foundation of innovation. They make innovation marketable. They give trust to the consumer when they will invest in innovations, and they give orientation for manufacturers to produce according to these standards. And to be successful with products for the AECS, we need international standards that go beyond the current limits of product standardization. To realize the AECS, we need communication and automation from power generation to power usage. This will enable us to overcome volatility in renewable energy generation.
Thank you. I think somebody would like to ask a question from the front. Was it Kishore or somebody next to Kishore? Would you like to ask a question? No, I should.
No, I think I'll defer. You go ahead.
Okay.
Yeah, I had this question since the morning. I'm
Could you,
Veena.
could you introduce yourself? Sorry.
Yeah, I'm Veena from Bosch, working for Bosch as technical expert on EV charging. My question, as serving some of the OEMs across the globe, this is a question also from the OEMs, electric vehicle manufacturers. There is some kind of instability in the grid. We are talking about connecting vehicles, anything and everything to the grid, and also collecting data, energy trading, in a reverse power transfer, transferring energy from battery to the grid. But because of instability in the grid, there are a lot of fluctuations, and which is causing component damage in the vehicle. And this, in the era of social media, people are using social media to blame on the system and the challenges which are faced by EV owners, and they are asking people not to buy electric vehicles. This is hindering the electric vehicle market and the interest in buyers. So what is our stake on this? How do we improve the grid stability, and how do we, also on the other side, how do we ensure compliance of all these standards? We have lots of standards on electric vehicle components, infrastructure, and even on the components used in the infrastructure, but how do we fulfill the compliance, and how do we mandate this?
Great question, and yeah, a real life case of something hindering the uptake of EV, and perhaps a market surveillance question thrown in there as well. Klaus, Wolfgang, you seemed ready to answer.
There is one tool we try to develop, and that is the flexibility. For sure, you can create huge batteries and stabilize, reset the grid, but that is only one method. The much better method is flexibility and organize and balancing the demand and response, because exactly you raised the technology for the electro vehicles. Currently, it's also in my country, the main people with electric cars, when they're coming home in the afternoon, they plug their car to their wall box, and then it is charged. But that's not needed. They need their car the next morning, so they have 10, 11, 12 hours time. If you have, now we are starting in Germany to have flexible tariffs. So some people working with these flexible tariffs plug their car, and then the car is charged when the price is going down. But that's not normal for everyone, but that should be normal. And the point, at the moment, it is not so easy. You need to program your car or whatever, so I do it myself, so I need to program my car, but it need to be as easy as driving with a car to a petrol station and charge it. And so it should be also in future the same. You come home, you plug your car, and automatically the system know when you need your car again, and know automatically when it is the best for the system, the best for the car, and the best for your pocket to charge the car. Then everyone is a winner. And you raised the point with the social media, that it's exactly something I gave. I tried to have an answer in a little bit before. Every transformation has losers, and that is here the point. You need no petrol station. So everyone who has invested in Germany, we have a nice system of petrol stations. They are looking great. There's a lot of money in, and you have some countries, their complete economy is based on selling oil to other countries. This will going down, and so you have some people who are not happy with an all-electric society. That's an issue. Not a technical issue.
Yeah, the challenge here is not on the availability or access to the energy, but the fluctuation causing surge on the component and damaging the heavy components in the vehicle. Replacement of the component, repairing of the component itself is a big job, and this is huge burden for the EV users.
Yeah, I mean, we know that fluctuation, stability, flexibility is a huge issue at the moment with microgeneration feeding into the grid, and as was mentioned, you know, the blackouts and we're writing the guide on resilience and flexibility. And I don't until we can resolve that, probably with more storage to be able to absorb those fluctuations. I don't see how that's going to be resolved immediately, to be honest. Kishore.
Yeah. So I have some I think I've been part of SG14, so I think I completely endorse what we are talking. But I'd like to add a few more dimensions, more foundational, totally from two different perspectives. One small, yes, electricity, clean electricity is all fine, and it adds sustainability or decarbonize or net zero. But what mostly we are trying to do in name of electrification, we are displacing, we are shifting the responsibility of environment. We are not looking at the larger bigger picture of overall environmental impact. Like if we take about the electric cars, like zero emission cars, what we are trying to do, we are using batteries and look at the carbon footprint of producing the batteries and the environmental impact of that. Again, there's the solar panels. Yes, solar energy generation of electricity from solar is clean. But how about the carbon footprint or the environmental impact of solar panels themselves? There's one question, I think, and then maybe second I'll come later. So if we have how do we address these larger, bigger picture of environmental sustainability rather than simply trying to decarbonize electricity generation?
Is there a way of offsetting that carbon? Has anyone, I can see Rajiv Chauhan sort of leaning forwards, but you mentioned the...
So actually the policymakers are not caring only for the decarbonizations. They are also bothered about the decarbonization at which place. Like where we have the highly populations, they want to keep that particular area, or they want to reduce the carbon emission at particular location. That's why they are more promoting to the electrical vehicles, because the carbon emissions is like 500 kilometers from the Delhi. That will not impact the human health in Delhi that much as compared to if we'll run the fuel-based vehicles in the Delhi. That's the one constraint. The another one is like the carbon emissions, as I mentioned earlier, that battery also, production of the battery also, the carbon emissions is there. So based on that, that's why whenever the person will visit to the electric vehicle showrooms, they generally ask the first question. They don't ask for the money. They ask the first question, how long per day you are going to drive your car, so that the overall carbon emissions will be saved or not. That's the first suggestion they generally give to the user. Either you are going to run the electric vehicle for more than 100 years, more than 100 kilometers, then it's worthy. They are not asking, okay, this is my vehicle, just buy it. They ask the first question. Sir, I have visited many times in this year, so generally they ask this question first. You know, and one questions we got from the boss side also. Actually, one of my students are working over there in the Bangalore center. So he has done BTech project under me, and their project was got the global competition organized by IEEE in the Zurich round. They got the first prize. So basically the thing is, whenever we are making the systems at the company levels, so how long you are testing your product? How much robust is this one? That is also the constraint. Like how much fluctuations, what voltage level, up to what voltage level it will sustain. Because the voltage at distribution level, because this will connect it at the distribution level. And the distribution level voltage will vary as per the load conditions. And this decrease significantly in the peak winter and peak summers durations. So my recommendations will be like, I have seen this type of system in the Europe, like whenever I visited the University of Manchester as a scientist work over there. So they have the industrial partner with the academia, or they are developing the lab in collaboration with the academic institutions. So basically the proper long-term testing for the different cases can be studied. So in this way you can improve your systems. And it will not only helping you to make the more robust system, as well as you will later on get the skilled engineers from the academic institutions that may save the cost of the training as well.
Dr.
It's
Khan,
my suggestion, not like the...
sorry, Doctor, you did not address my concern. My concern is not what policymakers are doing. Is this the right holistic approach that we are adopting? Because we are not addressing the bigger picture of overarching sustainability and environmental concerns by displacing the responsibility of carbon emission from the car to this, or from electric generation to some other ecosystem. That is my basic question. So is there any way forward we can address it holistically? That was my only question.
The question is the carbon footprint.
Overall environmental impact of decarbonization of electricity infrastructure only. We are only focused on electricity infrastructure decarbonization, consumption, generation, whatever. But then we are shifting, like I mentioned, solar panel manufacturing itself has got very negative environmental impact, is very well accepted, documented. Similarly, battery. So how do we address this holistically? Is there any strategy as structured approach that we can adopt to be more balanced and more holistic than focused? I'm not saying this is wrong. Absolutely not criticizing. Yeah. This is what we can do. We must continue, but then we need to also look at the long-term picture, larger picture.
As I was saying, really, it's that carbon footprint of manufacturing those technologies and offsetting that carbon footprint. And maybe a brief word before we go on to the final question, because we need to get on to the final poll.
I think that is something which is in view of the products. For example, for batteries, they are in development, and they are today batteries which are leaving today's factory are much more efficient than the batteries before. On the one side, they are reducing the CO2 footprint of the battery, and they increase the lifetime of the battery, which is are the two factors at the end. When you can use a battery longer, then the CO2 footprint per use is all the less. And so I think there is a lot of improvement, especially in the battery sector, but also in the solar sector. That solar panel from 20 years ago and the solar panel today, you have much more efficiency, and the CO2 footprint of each solar panel is also in our area. It is absolutely in view how much CO2 footprint a product have, even a solar panel. So it's not everything wholly only because it's electric. You're absolutely right. We have to look on that, but I think we are here also on the right track.
Yeah, I mean that's being quantified, isn't it? Product carbon footprint calculations and EPDs and other metrics that are used. But I think the message is, yes, it still has a carbon footprint, but it's reducing and preferable to fossil fuels anyway. Maybe a quick question before... Very quick. People could start scanning the code.
Namaskar and good evening. Undoubtedly, what is emerging is that EV charging infrastructure would be the best bet for everybody for a sustainable world and the economy. My colleague, industry colleague from Bosch just mentioned about one of the challenges with respect to the grid. I face another challenge, which is with respect to the getting construction approvals for installation and development of EV charging infrastructure in basement 2 and below in multi-storied buildings here in India. Although it is very well established that worldwide we do have approvals and standards in place where the charging infrastructure -2 basement and below are available. But India faces that challenge. I don't know how do we take it forward, and what would be the way forward in terms of that.
Thank you for your real-world question, and that came up, I think, in the previous poll as perhaps regulation is one of the challenges when it comes to systems. Any comment on regulation or legislation being inhibiting growth or development? And Rajiv Sharma?
See, this is the question which has to be best put to the policymakers, the regulators. And when they make policies and regulations, they invite comments, and they do stakeholder engagements. They do plenty of such engagements. But even if it was not possible for you to provide your feedback at that stage, they are open for comments at any given point of time. Even I would also suggest that you get involved with the work of the concerned technical committee in BIS, and they can provide you the roadmap of how to process on this further.
We have had consultations on that front, but probably the level of confidence with the regulators.
Yeah, see, they look for some kind of a robust data to establish the safety aspects with respect to the solution which you have. So if you can provide them that data with respect to safety.
Available through IEC or
Yeah.
international fora, the standards are there, and if the same is, probably there need to be more.
I think we'll have to put this question to the regulators.
All the regulators are
Yeah.
working and operating in silos or islands. They should be having a collaboration amongst themselves.
I think everyone has to learn with this new technology, even the regulators sometimes, and I agree completely with you. For e-mobility, it is absolutely key that everyone can charge its car at his home, because cars are, we always talk about it as a mobility solution. No, cars are mainly a parking solution. Normal cars are parking more than 20 hours per day, and mostly at home. And if you are living in a multi-flat, then you have a car park below, and therefore it is important to have here charging solutions for having a transformation of the mobility.
See, in India, we have a unique situation where we purchase parking facility in a building. So suppose I'm allotted a parking space which is, say, -3, and I want to have my own charging infrastructure independent there. The regulators are not allowing it. I mean, it's not there in the building code or whatever we have. So my challenge as a manufacturer is different than what my industry colleague just mentioned about grid. We have not reached that stage of having it, given to the grid. I'm not facing that problem. I face a problem which is I want to install -2 and below.
Well, yeah, I'm sure that there must be many applications, regional problems with installation. I think there was an example given earlier where there was some regulation was relaxed and it suddenly made life easier for somebody. But yeah, people living in flats that they park their car somewhere else. How do they install a charger? The challenges for different applications. So please scan this final poll. We're just coming to the conclusions. You should have had some time now to look at those, hopefully. So this is the question that I put to the panel right at the beginning. What's the one opportunity, critical opportunity that we must seize within the next 5 years? What's the most important next step? Who needs to act? And can standardization help with that? Can it support that? If you'd like to continue being involved with the all-electric and connected society, it was mentioned earlier, if you look on the IEC website, or you could Google it, IEC AECS, there's a web page on the IEC website dedicated for this AECS, which is really managed by Strategic Group 14. There's also a new page added to that, which has the building blocks and the matrix that you saw earlier that feeds into that. So, and then hopefully we'll have the open forum will go live. I don't put a time on it because we don't know how long it'll take to develop, but within the next few months, hopefully there'll be an open forum where everyone can contribute. So if you'd like to leave your name and address in the poll, then you you can have access to the poll results. You can still contribute to those polls they will stay open. How long do you think they will stay open for? A few days. The polls will stay open for a few days. And then you can be asked to be removed at any time. It's up to you whether you want to stay in touch with what's going on. So I think with that, I would like to really thank our Rajiv Chauhan, Klaus Wolfgang, Rajiv Sharma for their expertise, their insight, their knowledge, and giving up their time for everybody today. And it was inspiring. Any final statement, quick statement from Rajiv? A quick one.
Okay, so the main purpose, we are looking for the green energy, but green energy, my dream is like green energy at low cost. That's also the important point we need to incorporate here. Yeah, that's.
Thank you. Klaus Wolfgang.
Yeah, we started in SG14 to identify technologies which are relevant to realize the all-electric and connected society. With the help of the whole IEC committee, so also you, we want to identify gaps in standards and start projects to close these gaps. One of the first examples we have shown today is that we want to write together with the system committee Smart Energy, a guide on flexibility, and flexibility will be one of the cornerstones of the energy transition.
Yes, please, Rajiv.
Yes, this open forum is an excellent initiative. I think this will provide a lot of valuable inputs in how to improve the working in the SG14. Yes, and we should take these suggestions, like the ones which are coming in today's discussions, the cost benefit and the environmental impact benefit analysis also should be part of the discussions which happen in the SG14 to come out with clear opinions, suggestions, and ways whether this technology is better in terms of environmental impact compared to the other technology. That aspect, I think, should also be part of the scope of the discussions in the SG14. And we should work collaboratively. No north-south business. It should be a collective, joint effort. We should focus on the SDG 17 in this case, which is collaboration for goals. We should work collectively and find out solutions which are in long term, reduce the environmental impact of fossil fuels and climate change. That is the primary focus. We should work collectively towards that, pool in all our wisdom, pool in all our resources in making this world a better place, a safer place, cleaner place. Thank you.
Wow, thank you. And so you gave some suggestions on what you expect from SG14 to come out with. Rajiv, have you got any expectations of what you want to come out of Strategic Group 14? Just quickly.
Like green energy with energy efficiency, whatever the source of generation is there, that is the one thing, and the another is like the losses. How can we optimize that one? That's that can helps to reduce the cost of energy for the user end. Means it can be done with the user with the smart management of their appliances itself. So yeah, this is all.
Thank you. And we have some suggestions here from the audience. Use green energy as much as we can. Let regulators worldwide work closely together. Smart infrastructure to connect. Necessary and less necessary. Develop use cases. So safety, security and education. Misuse cases. So there are lots of suggestions here. Lots of material, if you like, for SG14 to take hold of and use. Klaus Wolfgang, as chairman of SG14, what are your plans?
Our plan is to say, now at this point, many thanks to panel and to audience and for all of these inputs. We will work on that and will try to get the essence out of that. And I hope you all will be part of the open forum and will provide further comments so that we are really here in the position to establish or to help to establish an all-electric and connected society.
Thank you. So with that, please could we have a round of applause for our panelists. No. Thank you.
Thank you, esteemed panelists. With that, we come to the end of this open forum. We are pleased to have with us Shri Praveen Khanna sir, Deputy Director General Planning and Coordination. So I would request you to kindly come on stage for presenting mementos to our panelists and moderator. Dr. Rajiv Kumar Chauhan. Mr. Klaus Wolfgang Klingner. Mr. Rajiv Sharma. And Mr. Andrew Evans.
Oh, thank you. Thank you. Thank you very much. It was a pleasure. Thank you.
Thank you, sir. I would request all speakers and DDG to kindly step forward for a photograph.
Thank you. I'll try it.
Yes, please.
Thank you.
Thank you,
Is that
everyone.
okay?
This brings us to the end of this workshop. As we wind up, we thank you all for being such a responsive and patient audience. Before you leave, we hope you visit the exhibition organized in Hall 14 in the ground floor. The exhibition will continue till tomorrow, 19 September, and we have products utilizing the very technologies and researches discussed on this floor, and it will certainly be an interesting experience. Thank you once again for being here, and have a wonderful evening ahead.